All right, as usual, I measured incorrectly, and I gotta keep cutting down, and it's getting uncomfortably close to that collet. So I'm gonna stop everything, shoot it out a little bit so I have a little bit of breathing room, and so I have to re-measure from the edge to there, and we'll have to clean that up. All right, I think I found my problem. I thought I had this tight, but look at that. That's not tight at all. So I gotta sort that out. All right, so of course, because I'm adjusted this, had to loosen it, it also could rotate this way, which means that all this flatness is for naught, but that's all right, I'm still cutting. So once I secure this where I like it, just make some cleanup passes that'll make a new default flat, and then hopefully I will never loosen that again, and then we can go from there. And it's also indexed to the edge of here. So, all right, so I've cut there and there. It's going well now that this is tight. Enough clearance that there's not going to hit that. And I'm manual feeding, which is a little slower, but I get a better feedback as to what's going on. All right, cutting fluid. All right, so I cut that. It was pretty simple, cutting all four sides, and then just try and fit this on there. So that's pretty good. I mean, there's always going to be a little bit of play. That's all right. I was going to try and make it a little snugger, but I think I'll just keep it to the spec that it was originally. All right, so on to the next step. There we go. So the one mistake was early on, I thought I had miscounted and ended up I had not, but then I added another 10,000. So that notch is incorrect. Everything else looks pretty good, at least for what it is. And then since I'm going to turn this down and then there's a collar going to go on it, I'm hoping most of that will either disappear as I shrink this diameter and or be hidden when I put the collar on. Anyway, but you can see, let's see if I can get this to go on. So there's a little slop in here. I actually cut this bigger than the 3/8 inch size because I knew this handle had a bit of slop in it, and there still is a little slop on top of that, but it'll, it's still pretty snug. Okay, so let's review what went wrong. So this is the one that I made and works fine, well enough anyway. It's got the hole in it. This is the one by Mark II that I was working on. It was going to have, let's see which end, yeah. So it was supposed to have a 3/8 inch thread here and the reverse Acme screw there. So what went wrong is I was making too aggressive cuts here, and it was far away from the chuck because the chuck was grabbing it there. And this was a weak spot because I cut these threads first, just because I thought I'd do those first and make sure I was doing those right, because I had already done an Acme thread once before. Anyway, this rode up onto the tool bit and bent it, and then when I was trying to possibly salvage it by hammering it back into place, it snapped. So that was the end of that. Also, I was despite having done Acme's threads correctly the last time, this time I had I had realized just on the pass that broke this that I had the angle the wrong direction because they were reverse. So I was used to, since I did this first, I had the angle, for these. I forgot exactly what the angle is, but I approached from the same angle, from the same side, different angle because Acme threads need a different angle for the approach, but I needed to flip it the other way because of the fact that they were reverse. Anyway, so, but the other thing I learned, so one thing was order of operations, needed to do it differently. Secondly, so this is 3/8 inch. If we look over here, I mean, that would work, but it's could afford to be a little bigger and it would still fit through the hole. And so the next size up, let's see, 3/8 would be 6/16, so 7/16. So if I do 7/16, it'll still be small enough that I can fit it through this way, which will mean a bigger nut there, and also means that the whole thing is going to be thicker here, so I'm less likely to bend it. Also, what I really need to do is do the Acme thread first, and then, well supported, do that last bit there. So that's what I'm going to do on the Mark III. Okay, so before I put it on the mill and cut those ends off, while this is still cylindrical and haven't done anything to it, I'm going to put some holes on the ends so I can mount it on center. Now I could do it in the chuck. My 3-jaw chuck is a little sloppy. 4-jaw chuck, I'm still not great at squaring those things up. And my lathe has, let's see if I can show you, I have these guys. So I can take the chuck out completely, stick the rod into this, and then with a drawbar, hold it in. And this should be the most concentric possibility. So, and then I just have a little bit stick out, and I will drill the little pilot holes for on center. I'll do it on both ends. Don't know if I need it on both ends, but it's never going to be this cylindrical because I'm going to start cutting threads and square things on it. So I figured might as well do this to start. All right, so first, I got the chuck off. I put this thread protector, one of my earlier projects. Got that in there, and then this, so there's this guy, and this is the 1/2 inch collet. Slide that on, and then that whole thing can go inside of there. I don't need much to stick out. In fact, the less it sticks out, the better. So I'll do that. And then this thing is a drawbar. Let's see if I can pan over. And it basically can stick inside this whole thing. Oops. Go in there, and if I tighten it up, it should, let's see if I can, so as I push this in, it should eventually, there are threads. Let's see if now I've lost the hole. Feed that through there. There are threads on this guy which will mate with this, and then it'll pull it into that sleeve. All right, put there. Just enough to hold on to it. See if I can get a bite on it. All right, so that's nice and solid. It should, I've got a foot pedal on here so it doesn't do anything, but let's see. That's pretty slow. Don't know if I'll do slow for drilling. I'll probably want to do it a little faster. All right, so I took off my rings in the glove, which I should have done earlier, but this is when I'm actually going to start cutting. I put a little cutting fluid there, and we'll fire it up. And like I said, my lathe has, so I can turn it on by there, but I also have a foot pedal for safety. So I've got to get in there and step on the foot pedal and get this to go like that. Let's see, why is it sounding like that? All right, I fixed it. It was, I had the idler gear sort of neither here nor there, so now it should be okay. Yep, all right, and then I'm just gonna feed this in a little bit. Yep. I don't know why it jumps like that. That's actually one thing I'm working on trying to figure out. So that is tight. Okay, so just to try and avoid that jumping, I took this and just tried to tap this in a little bit more, making sure there's enough sticking out on the throat that it didn't want to push the chuck out. And then everything else is tight. Let's see if that fixes my problem. Looks like that was all that was going on. So I'll just get this going on. All right. And we'll do that on the other side. I'll just flip the bar out, do the same thing on the other side. All right, since I decided to go with the smaller stock, I don't have to cut that all down. I've got the indexing on the end. I mean the center marks for later. I'm gonna stick it in this guy, and I'll figure out exactly how much I need to stick out to cut off. Also, because it's square, I don't have to remeasure. I just basically put it in the vise using the first screw I had to hold it together. I can just rotate it through all four sides to cut it. All right, so I got it zeroed out and ready to go. And then here is what I'm trying to do. So that's a 1/2 inch circle, 1/2 inch rod. 3/8 inch is what I'm trying to cut the square to, which is 0.375. Total difference means I'm removing 0.125 inches off of it, but of course I'm doing it from both sides, so I'm actually removing 0.0625 from each side. And then I'm trying to measure this. This is after first cut. What I really mean is after I've finished one side, what is the remaining dimension from the curve that's still going to be there to the flat? Because last time I cut this, I meant to make it a little fatter, and I ended up coming right on spec, but I wanted to be a little fatter, so I want to actually sneak up on this a little bit. Okay, I'm glad I sat down and thought about this for a minute. This isn't going to work because I want to be able to test thread it onto this. This is probably a little worn, so I actually want to cut a little less deep for the Acme threads than might otherwise need to do. So I want to test fit as I go. Now, the problem is this collar, I haven't even cut it down, but if I cut it down to match this, I still can't thread this through because it's bigger than the diameter of the threading in there. So I will want to turn this part down and slide this on to try and fit it. But so I got to turn this down, but more importantly, I don't want to take the thing out of the chuck to fit it, so I gotta flip this whole thing over. Maybe I can grab it by this collar, 1/2 inch collar there, with this, choke up on it, and then do the Acme thread from there, and make sure that the remaining bit is cut down enough that I could slide the jaw over for test fitting. Good thing I did that before I'd made any threading cut. Okay, so we want to do 8 threads per inch, which if you look on this chart, there's 8, and it says the top lever could be in the left, center, or right, but 8 says right. That's the lever here, so I want to go all the way over that way. The other thing is the sliding gear needs to be in. I took off the cover so we can see what we're doing here. That's this gear, needs to be in, so that's in. And then the last thing is the tumbler has to be in the row for the 8. So it's way over here right now. I gotta move it all the way over. 8 is the last hole there, so switch hands. There, so I'm in that tumbler. I'm in this gear is to the right, and the sliding gear in the back is in. So that's all I need to do to 8 threads per inch. Okay, so because I have that hole in the middle, a centering hole, I can put this on the live center. Also over here, because the diameter still hasn't changed, I can put this end in, it's 1/2 inch. So I don't have to deal with the unevenness of a 3-jaw chuck or spending a bunch of time getting a 4-jaw chuck dialed in. And I'm going to do the reverse Acme threads. And then last time, you're supposed to be at a 14.5 degree angle. I was at 14.5 degrees this way, which is fine if you're doing regular Acme threads. I wanted to do reverse. So it had to be 14.5 this way, which I did not do. The other thing is, so that's the approach of the compound, but this tool still has to be squared to the work. So that's where this thing comes in. And dial this back out. Oh, I guess I'm gonna have to move that tool back a bit. Oh, well, maybe I can do there. There we go. So I'm just squaring that to the work. Let's see if I can see that better. Don't know if you can see, but I hold this. Let's see if that, I'm going to push this in. See if that'll hold so I can see what I'm doing. No, okay. Get this at a better angle. Okay, yeah, so what I'm doing is, if I back this out, this could be anywhere. Just trying to get it square to the work. Once that's square, then take a big ass wrench and tighten that down. Keep that there just to help make sure it doesn't creep on me. Double check my work. All right, and make sure that's extra tight. All right. So in theory, let me zoom out. So in theory, this is square, that's got the 14.5 degree turn. I just have to make sure that the gearbox is all set up for turning the threads that I want. All right, here we go. Over here, wait till we get So remember, I'm going to wait to let that go past just because I can't see what I'm doing through the camera. We'll do it just before the 2 there. And go. This is about 3 thousandths. Seems to be cutting all right. I can cut heavier cuts, except I'm afraid of bending the shaft, so that's what it's going to be. And it just goes all the way to this end here, and when it gets to there, I'll throw this lever again to stop the progression. Alright, so notice it's in the collet there, and it's just on the live center here, and seems to be going okay. Just got to be careful, don't do heavy cuts, because I don't want to bend this. Of course, this is not as narrow as it was last time. Okay, to do the 14 threads per inch, there's 14. So you go all the way over here, and according to that, that wheel has to be in, which it still is. And where was it? 14. And the lever has to be to the right, which it still is from the previous 8 inches per thread. The only thing I had to do was move all the way from this tumbler, where the 8 is, all the way over to this tumbler to get to the 14. All right, so I've got the steady rest, and I've cut the 7/16 threads here, and trying to dry fit it. So that's going to work. So this is obviously longer than I need. I'll put it on the vise and figure out how far I have to cut it off. I might put a washer there, but we're getting very close. That's my word that we didn't cut deep enough. Still deep enough. That's maybe we didn't. Alright, so I gotta cut this down from that diameter all the way down, just to cut the corners on here, so that this guy will actually fit on there, which he doesn't quite right now. Okay, so we got this collar on. Just have to put a set screw. And then way over here, I just need to, I'd put a washer in there, and then the 2 nuts. Just have to figure out where to cut it off. Of course, so I'll just take my fancy stare at Sharpie. This is how I think real machinists do it, right? They're just very precise. Just color it with a Sharpie. That's going to be where we cut it off and taper it a little bit. And then we'll be done. All right, finally done. So this, I'm going to call this the Mark III because the Mark I worked well enough for me to be able to make the other ones. Mark II, as you know, died a horrible death on the lathe. But I learned some things from that, which I incorporated into this Mark III. So we got the 7/16 thread there. Interestingly, I probably didn't need to do this, but obviously that's the 1/2" Acme thread. But as you can see, so the jaw goes there. If you looked at the underside, something like only this part of it is actually where it's threaded. So with that in mind, I probably did not need to thread this visible Acme. This could have just been a regular straight shaft. It doesn't matter. I did it close to where it exits the vise, and then that I made that a straight shaft. So, and then the other thing is getting this so that you can wind it all the way without bottoming out anything other than the vise. So you get the maximum width. That seems to have worked. Just one simple set screw works fine for opening because the closing force is done by these two nuts. Now, if you look at the video, if you look at the old catalog, it had the jam nut on the outside. I looked on the internet, and apparently there's some debate. I may change this. The main thing is, I cut the thread. Look at that. I cut it, but it looks like it's just barely. Well, it's good enough. Maybe I could choke up on that a little more. But so I also made a washer in there. I don't know if that's strictly necessary, but it's there in case I need it. You know what? I might change up jam nut on the outside or inside. It's a little confusing as to which actually would be the more logical force, so that the big nut is doing most of the work of the load. Anyway, so that's doing the clamping force. This little guy all it's doing is just providing enough drag so that this will open up instead of just work its way through the vise. And that seems to be working just fine. So this finally, after a long, arduous journey, I finally have a working screw for my vise. All right, so one of the side benefits of doing all this, obviously it took countless hours to do it and lots of mistakes. This was not really about the money, it was about learning how to make things on the lathe and the mill. So as far as that went, it was a success. I'm happy with it. It works well. Again, because this is so worn inside, this Acme thread is actually not even truly fully Acme. If I had an Acme nut, it would not fit on this because this is actually cut not as deep to compensate for the slop from the wear in here. But the other thing I learned working with this vise is you can see here, this is looks like somebody milled it and then up that way, and for some reason stopped here. Did the same thing over here. There's some divots in there from, I guess, mistakes. Also, there's random, like, what's this? I don't know how you would manage to accidentally put a giant divot in there. I don't know. So, and then of course the way these are parallels, you're supposed to use these to make sure that you hold something exactly a certain height off from this. So you're supposed to be using this as sort of an indexing surface. But you can imagine if you have a piece that's bigger than that, it's, you know, you can see here, I got the, see if you can see the indexer. So now I'm just going to turn this handle so we can see this moving across there, and you can see, you know, it's not great. Now, maybe a future project would be to take this apart, take this jaw off, and then make sure this is absolutely flat, and then machine a new surface here. Can't do too much more of that, because then once I do that, then I have to take more shims out to take out the more slop that I would be creating by removing this. That seems, you don't want to screw that up, so that might be a future project after I've done some more research. In the meantime, however, dun dun dun, what I did for $64, I bought myself a little Chinese replacement. So if just getting a working vise was all that mattered, that would have been the far faster and cheaper method than what I did here. You can see the Chinese one is similar, but it is a little bit higher, just a little bit higher. It does have a rotating base, just like this does. And I had to do some work. I had to, the little indexing registration pins that go into the table, I had to cut those down. But, you know, I get brand new jaws that are not all dinged up, and the bottom down there, well, it's got some swarf in there. It's not messed up. So let's see if you can see in there. Yeah, it's nice and flat. So if I'm using that as an indexing surface, I probably am going to use this vise rather than this one. Also, I did take this apart and look at it inside. Obviously, it's sort of a budget solution, so it does not have the shims that this does, so there isn't sort of a easily user identifiable way of tightening this up once wear starts to happen. So there is that. This has a little bit more longevity as far as that's concerned. Of course, this also uses everything as metric, so this is a metric stud. It came with this metric wrench thing. It would be nice if I could use this on this, so maybe at some point I'll mill this down so that I can put this on there. Maybe not, we'll see. Again, if it was just getting a something that would work and well enough, this sort of no-name brand replacement vise for like 64 bucks, it's a way to go. This is original to the machine, so for people who like collecting, I guess that's would be more desirable. This would be great if I could fix this part, which maybe I will, because it is still a little more lower profile than this, and this machine doesn't have a lot of room to move around, so, you know, having a little bit extra is good. But you know, it's I don't know, 70 years old. It's had some serious wear issues and dings and mistakes, and I'm likely to have more. But you know, in the end, I'm glad I made the part for this, even though I'm probably going to be using this for a bit. You know, right now I got them both on the table. We'll see how it goes.